Okay, you're all welcome to my class today, and I'll be discussing simple linear regression. Okay, so in this short lecture, I'm going to walk you through what regression is, what a linear regression is, and why we do them. In particular, we're going to focus on simple linear regression. Okay, so regression analysis serves as a powerful tool for both understanding the relationship between variables and making predictions. So there are two main objectives for doing regression. The first one is to study the relationship that exists between variables, and then the second is to make prediction. So when you study the relationship, you want to know whether there is a significant relationship between them. It's what we call, to be more precise, a statistically significant relationship between them. So we have statistical tools to measure this. Okay, because we don't want the relationship to be just noise. We want to make sure that this relationship is significant. So we study that. And once we find out the relationship between them, we want to use that relationship to make predictions. So these are the two main objectives: understand the relationship and use the relationship to do predictions. Okay. And the way we do predictions will be to fit a model in our data, and then we can then say, make predictions, for example, say something about data points that we didn't have before. Okay, we can use that to make informed decisions about the future. Okay, so we are going to study regression, but especially the linear regression. This is the simplest kind of regression, so we'll focus on the linear regression. So the basic assumption for you to do a linear regression is that your variables have a linear relationship. Okay? We have done in general mathematics, you have done things like equation of a line and things like that. So we want to know if there is some linear relationship. The linear relationship will mean that maybe as one is increasing, the other one is decreasing, but in a linear way. Okay, so if we have a linear relationship with them, with the variables between the variables, then we can do a linear regression. There are two kinds of linear regression. One is the simple linear regression, and the other one is the multiple linear regression. The difference between them is that while one of them uses only one predictor variable, the other one uses more than one predictor variables. So if you look at in this example here of house size, you're using only the house size to predict the price of the house. So the house size which you are using to make the prediction is called the predictor variable, and the price, which is what you are predicting, is called the response variable. Okay, here we're using only one predictor variable. In the multiple case, we have three predictor variables. So we use the age, the income, and the education to predict the happiness score of an individual. So that's the difference between them. One uses one predictor variable, the other one uses more than one predictor variable. In this class today, we are only focusing on the simple linear regression. So we have only one predictor variable. Now, just to mention that, again, one of the assumption to do a linear regression is that there is some linear relationship between the variables. You can tell just by looking at this data that you expect to have a linear relationship between the house size and the price. You know that if the house size is big, you expect the price to be big. Okay, so there is some kind of linear relationship between them. But in the case of example that you see here, this is predicting exam score just using the number of hours that an individual sleeps. Okay, there may not be a relationship. You don't expect that there to be a relationship between the number of hours an individual sleeps and their performance in an exam. So in this case, you expect that there will be no linear relationship between them, so it may not be a good idea to try to do a linear regression. Okay, so now let's go into properly into the linear model. So what is the whole essence of doing a linear regression, a simple linear regression in this case, is to create a model which we can use to make prediction. Okay, so a simple linear regression model looks like this. So you have the predictor variable x, and we want to use it to make a prediction about the variable y. And so we want to fit a linear model. So the linear model will be a straight line, it's a straight line graph, where what you used to think about, the x-axis will be the predictor variable, and the y-axis will be the response variable. And then b naught or beta naught here will be the intercept of this line with the y-axis, and b1 will be the slope of this line. Okay. So because you're trying to fit this model through your data may not be completely linear, meaning that some of the points will be on this line and some of the points will be outside of this line. So the difference, the gap between what, the value on this line and the actual data point is what we call the error. Okay, I'm going to show you a picture in a bit. In fact, let's do that. So this is what you have. So the green points are your data points, and this is the line that you want to fit. You want to fit a line through your data points. With this line, you can make predictions about, so if I give you a new data point, I give you a new x value, you can then predict what the y value will be. Okay, and so these are the E is the error that we have. So it's the difference between the predicted point and the actual point. That's what this E stands for. Okay, and then so we want to get this linear model, which is a straight line, and then we get the equation of this straight line. Okay, so how do we want to get, what do we want to do to get this line? Well, what we really want to do is to minimize, we want to get this line in such a way that this error, the difference between the predicted value and the actual value, is very small. Okay, so which means, so this is what we want to do. We want to fit a line that looks like this. So we want to choose beta naught and beta 1 such that the line here that we get the predicted value minimizes the error. This error becomes as small as possible. So what we do is we take the difference between the actual value and the predicted value, which is that, and we call it error or we call it residual, and then we minimize it. It turns out that the best way to do that is to first of all square the errors and then minimize with respect to beta naught and beta 1. Okay, this is why the name is called least square method. So we are squaring things here, and then we're trying to minimize this function. Well, okay, so this is S, which is the function. We want to estimate the values of beta naught and beta 1, which is this ones, that minimizes those errors. And if you've done optimization in differential equation, in differentiation, you know that you have to differentiate S with respect to beta naught, you get this equation. Do it with respect to beta 1, you get this equation. And when you solve both of them for beta naught and beta 1 hat, you get these expressions. Okay? So whenever we do a linear model, we're going to be using Excel or any other package. If you are doing least square method, this is how these values are computed. Your linear graph that you get, we have this coefficients. Coefficient of the constant term beta naught is going to be computed from beta 1 hat, which is computed like this. Remember that the x by the mean of x values and y by the mean of the y values. Okay, so this is how we get the equation of the straight line that we fit through our data. And once we have this equation, we no longer need to. So this is the equation we are looking for. Once we have this is the equation of this line. Once we have this equation, when we can just plug in, once you plug in any x value, you get a y value, the predicted value that we expect to get. Okay, so I think I want to illustrate this with the aid of an example. Okay, so imagine that I have this information here. I have temperature on this side, and I have the energy consumption. So the temperature is the predictor variable, and the energy consumption is the response variable. Okay, and we want to get a linear model for this data. I want to do this in Excel. Okay, so the way to do this in Excel will be to input the temperature and energy in an Excel sheet, put them differently, and then you can insert a scatter plot. A scatter plot is going to allow you to visualize the data and see, if there's a pattern there. Okay, whenever you want to do regression, this is the first step, is to do a scatter plot to see if there's some relationship between them. Of course, you can compute things like correlation to know if the correlation is high or not. Anyway, so but to get the trend line, the line that I talked about, you have to insert it. So that is, you go to trend line, choose linear, just add it. And if you want to know how strong your model is, you have to display the R squared. The R squared will tell you how strong your model is. Well, what is R squared? R squared is just something that has to do with errors. The smaller the error, the better your model. And R squared is one way to compute that error. Essentially, R squared measures the proportion of the error that is explained by your data over the total error. And so the closer it is to one, the more the error you have is explained by your data, and the better the model that you have. Okay, we can go through into this in detail, but I just wanted to give you an idea. And then your result is going to be the equation of the line. So the equation of the line that you're going to get, just y hat is going to be beta naught plus beta 1 x. And then you can use this to make your prediction. So for any x values, the predictor variable, you can use it to get the response variable. Okay, so I I want to finish here, but it's not difficult to go and do this now in Excel. Just follow the method that I've described here, and you can do that in Excel. So first of all, put the data inside the scatter plot at the trend line, and you can display the equation of the trend line and the R squared. The higher the R squared, the closer the R squared is to 1, the better the model that you have, the model that is given by that equation. Okay, just to summarize, today we have learned about regression analysis. We say that this was a method we use to understand the relationship between variables and then use that to make prediction. In particular, the linear regression that we did today assumed that the relationship between the variables is linear. The simple linear regression is where the predictor variable is just 1, and the multiple assumes more than 1. And in the end, you get this trend line, which is an equation of this form. The coefficients give you are determined by the least square method, and you can you can do this in Excel. Okay, so let me just see. Okay, there's no way. Okay, I think we can finish here. I wanted to insert an Excel sheet, but I can do that in the next class. Okay, I hope you enjoy the class, and see you next time. Bye bye.